All right, so I know that people are probably going to be at different places in the process of going through. I think I'm going to sort of go through all the exercises, and then you can just kind of skip around and see the parts that you want. Um, so, there's a couple different ways that you can convert between units, and you should really just do the one that you feel most comfortable with. So I'll do two. I'll do sort of moving decimals and then multiplying by a conversion factor. And so the most important thing is just to remember that, the most common units that we're going to use for things that are really small are a millimeter. And obviously these are, I don't know where my ruler here, but, these are obviously going to be the smallest marks that you can see on a metric ruler. And then a micrometer, which is kind of what we're going to use to talk about cells. And you could have a prokaryotic cell that's maybe 1 micrometer. And then you can have eukaryotic cells that might be somewhere up until 500 micrometers, but probably more like 100 micrometers. So this is what we're normally going to use to talk about sizes of cells. And then you might talk about nanometers in terms of things inside of those cells that are really small. And so if you could just remember that it's about 1,000 times difference between a millimeter and a micrometer. And then obviously just remembering that as you go down, a micrometer is smaller than a millimeter and a nanometer is the smallest. And then going from micro to nano, it's another 1,000 times difference. And so, you're looking at, if you want to convert between a micro and a nanometer, you can think that there's 1,000 of really tiny nanometers in a micrometer, and there's 1,000 tiny micrometers in a millimeter. And then if you wanted to convert between these two, it would be 10 to the sixth difference. Okay, so if you can remember these 1,000 times differences, so if you look at 500 micrometers, and some people might be able to do this a lot faster. Like you might even just say, "Oh, in my head, I know what that is." So if you can remember that it's a factor of 1,000 times, right? And if you start from this decimal point, you can just think, okay, a micrometer is small, so it's going to be not a lot of millimeters, and you're going to know that you're going to move it this way. So you're going to move it 3 decimal places for 1,000. And then you can say, oh, it's 0.5, it's half of a millimeter. So with 20 micrometers, you can do the same thing. So it's going to be a small part of a millimeter, and I'm going to move this 3 times. So here's my decimal point. So I can say this is 0.02 millimeters. And for nanometers, I don't think I have enough spaces to move these. But So in this one, you're thinking, okay, a micrometer is bigger than a nanometer. And so now I'm going to add 3 in the other direction. So I'm going to go 1, 2, 3. And I can add my zeros there. So this is going to be 20,000 nanometers. So let me just do these really quickly. So you've got 5 millimeters. So a millimeter is bigger. So it's going to be 1, 2, 3. So 5,000 micrometers. A millimeter, same thing, is bigger. So I'm going to go 1, 2, 3. So this is 100 micrometers. And then I'm going to go, nanometers is smaller. So I have to go the other direction. 1, 2, 3, 0, 2 micrometers. So you might be able to just, kind of easily do this. If you're not sure or you think you're going to mess this up, one of the things that I really like to do is write myself a conversion factor. So if I say 500 micrometers, I'm going to multiply by a conversion factor where I know that these two units are equal. So I'm going to say, look, I want something that's going to get rid of micrometers from the top. So I'm going to put micrometers on the bottom, and I'm converting into millimeters. So I'm going to want that on the top. And then I can just really easily say, oh yeah, micrometers are small. So it's 1,000 micrometers to 1 millimeter. I'm doing the exact same thing. So if you do 500 divided by 1,000, you're still going to get the same number. But you can just see that these units are going to cancel out. And the reason you can do that is because 1 millimeter is exactly equal to 1,000 micrometers. You're just multiplying this number by 1. But you're doing so in a way that you can get rid of the unit that you had and convert to another unit. So you can do that in all of these cases. So this one would be similar. You're multiplying by the same conversion factor here. So let's say that I had 20 micrometers. Oh, sorry. Yeah, micrometers. So I'm going to cancel out micrometers on the bottom, and I want nanometers. And then here you just have to say, oh yeah, it's 1,000 nanometers to 1 micrometer, right? So you're doing the same, you're multiplying 20 times 1,000. So I'm not going to show you all of those, but hopefully I didn't mess up any of these. But this is just a really good way to convert between units. So the next thing that I'm going to look at, and maybe I'll save that before that goes away. So the next thing that I wanted to look at was this practice. And I'm going to show you, so I used this, teacher made this presentation. I thought it was pretty good. I really like just thinking, and I think BioNinja talks about it this way, but magnification equals the image size over the actual size. And it's exactly like this, right? The measured size of the drawing is your image, and your size of your specimen is the actual size of the object that is being viewed under the microscope. So I just think this is a little bit easier, and I'm going to use that notation because I think it's a little bit easier. So in all these cases, and I don't know if I'm going to come up with the exact same numbers that they did, but and when you do the practice later, you can actually just, if you had a piece of paper, you would measure the piece of paper as your image. And in my case, I just measured the screen for the practice thing that we gave you. So here, right, this is pretty much at the end. So you're looking at how long is this? And so you're saying, okay, 54 millimeters is the size of the image. And then this is our actual. We know that it's 200 micrometers long. And so I'm just going to show you, because on the other page, the next page, there's the way that you could put these two units in the same, right? So if I said, oh, I'm going to write, so let me try this. Okay, so magnification equals the image over the actual. And you could just write this. You could say the image 54 millimeters is really, and then you could multiply by 1,000, right? Or you could move your decimal places 1, 2, 3, 54,000 micrometers, and then divide by your actual of 200. And so that's 27. Yeah, 540 divided by 2. So it'd be 270, and then we use that as like times or magnification, but we could say the magnification is 200. The other way, if you think you're going to mess these up, you could say 54 millimeters, and then so divided by 200 micrometers. You can multiply by that conversion factor. So you can say, I want to cancel out micrometers, I want to cancel out millimeters, and then you can say, I know that it's 1,000 micrometers to 1 millimeter, and you're going to end up getting the same thing. Right? So these millimeters cancel, these micrometers cancel, and so you're going to get the exact same thing. So here's your 270. I'm just going to tell you that for IB, you don't necessarily have to round to one significant digit. And then, if you go back to your measurement here, we know that there's some uncertainty in that measurement, but it's probably not, 54, we can say that 4 is a little bit uncertain, might be closer to 53 or 55, but I think you can still leave 2 significant digits in your answer. So I'm just telling you, if you want to write 1 significant digit, that's fine, but you could also leave that as 270. All right, so actually, I realized that practice problem number 2 requires that you know that's about microscopes and how to calculate magnification and size of the field of view in the microscope. And we haven't done that yet because we're not in school and we don't have microscopes. So I'm just going to show you guys practice 3, and then I'm going to switch that slide so that you guys can actually do that question. So in this case, you're using the same formula, but you're looking for the actual size. And so again, let's see, I'm not sure what they're using for the length here, but so it's probably like 18 minus 1. So you've got 17 centimeters is the image. And then you have the magnification. And so what you're going to do is just this magnification equals image over actual. And then since you're looking for the actual size, you might as well just rewrite the equation. Actual equals the image over the magnification. And then we can do, so let's do 17 centimeters as millimeters, 170 millimeters, and then divided by the magnification, it's 200. So if we do this, we're going to get our answer in millimeters, which is okay. So we're going to get point something. Let's see here. So 170. So 0.85. It's supposed to be an 8. 85 millimeters. And then if you multiply by 1,000, you're going to get 850 micrometers. So same equation, you're just drawing it a bit of a different way. So let's see. Yeah. So I didn't use 18.1, but okay, so I think these should be pretty straightforward based on what we've done. But let me know if they're not. And I just wanted to show you this one because I realized that it's a little bit different. So I think most of these are magnification or the actual length. So for these, you always want to use the scale bar for your, so if you're looking for magnification here, right, you want to use your scale bar, measure this with a ruler. And in this case, I got, so I think I measured this as 1.22 centimeters or 12.2 millimeters. And this is the image. And then the actual size of that scale bar in real life, it's telling you that this, about 1 centimeter in the drawing is equal to 1 micrometer. And then because you're looking for magnification, you can cancel your units. Millimeter, so it's supposed to be millimeter. And then you've got 1,000 micrometers is equal to 1 millimeter. So that's 12. This one, it probably makes sense to round to 12, but so it's about 12,000 is the magnification. So that's not anything different than what we've been doing. So here we're looking for the length or the diameter of the nucleus in real life. So what's the actual size of that? So in this case, right, magnification we should be able to get using the scale bar. So measuring that length. Yeah, and okay, so this one I got, it's 8.5 millimeters in real life, or sorry, in image. And then the actual is 400 nanometers. So to find the actual size of the nucleus, we're going to measure this with a ruler. And I measured, so the nucleus, I measured this in my drawing as, what was this, number 2A? Okay, so I measured this as 3.05 centimeters. And I just know that centimeters are not great. So I'm going to change this to 30.5 millimeters. And then here's the thing now. I can use this scale bar as a conversion factor. So I can say that 8.5 millimeters in the drawing is equal to 400 nanometers in real life, the actual size. So what I can do here is I can treat those as equal because they are equal in this drawing. So I'm going to say 8.5 millimeters in my drawing, right, which is going to cancel out. This was 30.5 millimeters in the drawing, is equal to, oh, whoops, why did I change that to 8.4? 8.5 is equivalent to 400 nanometers in real life. So I'm going to cancel those units. And then let's do this and just see if this makes sense. So 30.5 times 400 divided by 8.5. So I got, well, equals. So I got 1, 4, 3, 5, blah, 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 all these decimals. And so here I am going to look for, so in this case, I have 3 significant digits, but I'm limited by, I only measured the scale bar to 2. So I'm going to just use 2 significant digits here. So it's 1,400 nanometers. And then this makes sense, right? Because look, this was a little less than a centimeter, the way that I measured it. And this was 3. So even just looking at that, I can say, okay, so maybe this is like 500, 500, 500. So you want to make sure that your answer makes sense. And that does seem to, right, that's almost 1,500 nanometers. So that definitely is close. Okay, so I think this should be okay, but I'm gonna post the answer key and then feel free if you have questions to ask me.